Alright, for the third part here, we're starting with number 6 here. We want to find all the values of theta between 0 and 360 degrees for sine of theta equals square root of 2 over 2. So here, whenever you're trying to figure out your theta value, or in other words, your angle, what you want to do is, first of all, make sure that the mode of your calculator is in terms of degrees. Depending on your calculator will depend on how you check that. If you're not sure if it is, you can always check in class here, especially if you're getting a different answer than what I'm getting here. Because what you're going to have to do is you're going to have to click on the inverse sign. So it looks like a sign and then it has to the -1 power. So normally to get to that, you have to press either a second or a shift button, and then the sign button will give you the inverse sign. And then you're going to have to enter in what we have on the other side here of the square root of 2 over 2. So you can think of the inverse as the opposite of your sign. So it gives us what the angle would be here. So if you do the inverse sign of square root of 2 over 2, here you should get 45-degree angle. So that'll give us one of our angles there. And that would be what's considered the reference angle. So if we're thinking of it on a graph, we would have our 45-degree angle right in here. And if we're thinking of it visually here, if we have sine is the square root of 2 over 2, remember sine is the opposite side, which would be this side, over the hypotenuse, which remember is that longest side, or that side that goes to the origin of the graph there. So in terms of a graph, it would look something like that. But here, remember that your sign is also positive if you're in the second quadrant, because your y values are positive there too. So we can create a reference angle over here, where this side is still the square root of 2, and the length of this is still 2. And then inside of this angle is also a 45-degree angle. But what we would need to do then is to figure out what that entire angle is. So let me try and resketch it here without the first 45-degree angle, just to make it a little bit more clear here. So once again, we have inside of here is 45 degrees for this bottom angle down here. So if we want to figure out what the angle is from our positive x-axis until we get to that terminal side, that diagonal length side, our radius there, until we get to that terminal side, we can do that total angle that we get whenever we go to the negative x-axis. Remember, the negative x-axis goes to a total of 180 degrees. And we can subtract off this 45-degree angle to figure out what this angle is here. And that'll give us another angle for theta that would also give us the square root of 2 over 2. So if we do 180 minus 45 for our other angle here, we would get an answer here of 135 degrees. And you could always go through and double check these here by plugging them back into your sine functions there. And whenever you do sine of 45 degrees, or if you do sine of 135 degrees, both of those should give you an answer of your square root of 2 over 2. But of course, in your calculator, it's going to give it to you in terms of a decimal. So to check to make sure it is actually equal to the square root of 2 over 2, you'll want to do square root of 2 divided by 2, see what that is as a decimal, and compare that to what you get whenever you do sine 45 degrees and sine of 135 degrees. So if you go through and check that, you should see there sine of 45 degrees and a sine of 135 degrees, then with both of those angles, you get that answer there of the square root of 2 over 2. And make sure, like normal, if you do have questions on this stuff, make sure to ask. But this is using what we call reference angles here. Used the reference angle of 45 degrees. If we're dealing with a cosine instead here, we would have to look for where cosine is positive. So remember, cosine has to do with x values rather than the y values. So then you would have to look in the first and the fourth quadrants instead. So it does make a difference of which ones you're looking at. Of course, in the homework, you'll get some practice with that as well. For the next one here, we need to figure out the value of theta. So that tangent of theta is equal to that number. And here we just want it between 0 and 90 degrees. So instead of going through and having to find it for all 360 degrees and finding more than one angle, we're only looking for one in this case. So once again here, we're going to want to use the inverse function. And this time we want to do the inverse tangent function, because the original function here was a tangent. So to cancel out a tangent, we use inverse tangent. And you're going to want to plug in all of the digits there of your number. So the 0.2125565,617. I'll plug all of that into your calculator whenever you're doing your inverse. And once again, for all of these, you want to make sure that your mode is in terms of degrees. Otherwise, you're going to get a different answer for these. So whenever you do that here, you should get 12 degrees for your answer. So here, once again, here, you should get 12 degrees. So make sure that you do know how to enter these into your calculators. And this, once again, is what your theta is equal to, what that angle is. The angle here is 12 degrees. So again, that's from entering in your inverse tangent function of the value that we are looking for. So for both of those, for 6 and 7, you're both using your inverse functions. And then for the next one here, we're trying to figure out what the missing values are in our triangle. So to figure out this missing angle for angle B, we've actually done that sort of thing before. Remember, all of those angles have to add up to 180 degrees in your triangle. And remember, if you have this symbol down here with that box, that means that is a 90-degree angle, a right angle. So if we want to figure out angle B there, we're going to want to do 180 degrees that we have for our total, and subtract off what we already have there, the 90 degrees and the 42.3 degrees that we already had to start out with. So here, if we do 180 minus 90 minus the 42.3, we get 47.7 degrees for that top angle for angle B. So up here, we would have 47.7 degrees there. Make sure once again that you're also working through these. Make sure you're getting the same answers there. If not, let me know. Because then to figure out the other sides, what we want to do is look at our two sides that we have left. We have A and B left. So here, for instance, we could figure out these using different things. So here, if we use, for instance, the 42.3 degree angle, so if we, for instance, call this our angle that we're using here down here, then that would mean that angle C would be our opposite side. Down here, the 120 would be our adjacent side. And the one that we had labeled as a little a there would be our hypotenuse. So don't get used to A, B, and C as being the legs and the hypotenuse. Depends on the setup of the triangle here. So here in this case, if we are using the 42.3 degree angle, then those would be your opposite and adjacent as I had labeled. If we use 47.7 instead, then the opposite and adjacent sides would switch positions. So it depends on which one you're using of how you're going to label those. So here, for instance, we could do tangent of our 42.3 degree angle there is equal to our opposite side, which is labeled as C, divided by our adjacent side, which was 120, and then solve for C. So for solving for C, we can multiply both sides by 120 to get the 120 out of the denominator like we've done before. So then that cancels out. So then it's a matter of entering in, see what you get whenever you do 120 times the tangent of 42.3. So again, depending on your calculator, depends on exactly how you'll enter these in. So you want to make sure you're practicing this, see if you know how to enter it. If not, let me know. You get 109.19. And our units here in this case was in terms of feet. So this would be in terms of feet. So 109.19 feet there for our side C. And then you've got a couple options in terms of solving for side A now. You could either go through and use the Pythagorean theorem to figure out that side, or you could go through and find it using your sine, cosine, or tangent functions here once again. I'm just going to box in what we had so far. We had angle B here already, and then we just found side C. So I'm going to go through and use it using the trig function, since that's the part that you guys aren't quite as used to here. So here in this case, we would have one way to set it up would be in terms of our cosine. Use cosine this time. Cosine of our angle. So in this case, though, we're given our angle. Let's use our angle here as being the 42.3. Since that's how we already labeled the sides here, in terms of our adjacent, opposite, and hypotenuse. And then cosine, remember I said adjacent over hypotenuse, so it'd be 120 divided by our hypotenuse, which we have labeled as A. So it's a little bit trickier if you have the A in the denominator, because now it's the A that you're multiplying by. So it's not always the number, just depends on whatever's in the denominator, whatever you are dividing by to begin with. So now we have A times that cosine value of 42.3 is equal to the 120. And then we'd want to divide both sides here by that cosine. So we're divided by cosine of 42.3 on both sides of our equation. So just like normal, if you divide on one side, you have to divide on the other side as well. So then here, after you get done dividing those will cancel out on the left side. So we have A then here equals approximately, so once again you're doing 120 divided by cosine of your 42.3. Some of your calculators, just like with some of the other problems, are kind of programmed backwards. So you may have to enter the 42.3 and then the cosine function, depending on how your calculator is programmed. But either way here, you should end up with about 162.24 here. And once again, this was a measurement of a side, so your units here would be in terms of feet. So make sure that you are labeling those in terms of whether you're dealing with the distance there or in terms of an angle for those. And then in the next video here, we'll go through number 9 next.